All right, now that you know how to divide, let's actually use that knowledge to find the greatest common factor. So what we're going to do is we're going to look at an expression that has more than one term. It might have multiple terms, and we're going to find out the biggest thing that we can divide out. That's going to be the greatest common factor. And it may have numbers, and it may have variables, or it may have only numbers, or it may have only variables. The key is whatever I divide out, numbers and or variables, every term in that expression has to be able to have that divided out. It has to be common to each one, and I want the greatest thing I can find, not the smallest. So here I have two terms, and I look at the numbers first. What's the biggest number that I can divide out of both the term with the 2 and the term with the 4? Well, I'm going to divide out a 2. That's the biggest I can do. I can't do a 4, that's too big. So I'm going to divide out, I'm going to do it like this. I'm going to divide out a 2 from both of them. Now I look at the variables. This front one has x squared. So it has essentially two x's there, an x squared that I could divide out. But look, the 4 doesn't have any x's. So I can't divide out any x's. It has to be common to everything in that red expression. So the only thing I can divide out on this one is a 2. So if I look at this first part, 2x divided by 2. So when I do 2 divided by 2, I get 1x squared. And now I'll look at the back part of the problem. So 4 divided by 2 is 2. And I do have a GCF. You don't want to leave that GCF. This 2 right here on the bottom that I found was the greatest common factor. I can't forget about it. I have to bring it down to my final answer. So I put it right here, and then I put parentheses around it. If you want to check it, then you can distribute the 2 back in and see if it turns back into the original red equation. If it does, you got it right. If it does not, then you messed something up. So look, 2 times 1x squared is 2x squared, and then 2 times 2 is 4. So this checks. This right here, though, is my answer. Don't just give us this. That's not correct. You have to put the GCF that you found out in front. Now, you may not like the way I wrote it. You could do it like this, 2x squared plus 4, and then divide by 2 and divide by 2. You end up with the exact same thing, 2 times 1x squared plus 2. And in reality, you don't need to show the 1 there, the coefficient of 1 in front of the x squared. So it doesn't matter which way you do it, whether you have a big division symbol or two smaller ones. But make sure you bring that GCF down in front. All right, now that one was relatively simple. Let's try the second example. So here we go. We got a new example. This one has 3 terms. So I'm going to have to find something that is common to all 3 terms, and it's the biggest thing I can find. Okay? Now, immediately I notice this out front. I notice a negative out in front. And you might want to add this to your notes. If there's a negative in front, you're going to have a negative GCF, or you want to take a negative GCF. Okay? So if you have a negative in front, then you're going to want to take a negative GCF. And this is written in what's called standard form, so it's in the right order. It starts with the biggest exponent, and then it goes to x with a 1 exponent, and then it goes to this term here at the end that doesn't have an exponent. It's just the number, the constant. So this is in the right order. Again, and I'll say it, if you get to this spot where you have a negative in front, then you want to make sure your GCF that you take out is negative. Okay? So, here we go. I'm going to do my big division. Again, you might want to do little small divisions, but here's a big division. And now I'm looking at the numbers. I know it needs to be negative because I have a negative in front. Now I'm looking at this number here, 9, 6, and minus 18. And I'm thinking of the biggest number that I can take out of there. So I kind of first start thinking about 9, but I realize this 6 right here can't have a 9 divided out of it. So the biggest number I can get out of there, surprisingly, is just 3. So I'm going to take out a minus 3. Now I start to look at the x's. Okay, let me get rid of some of these scribbles. So now I'm looking at the x's. This has an x squared, the first term. The second term has just an x. And this term down here doesn't even have an x. Now remember, it's the greatest common factor. That means whatever I take out has to be common, or has to be in each one of these terms. So since this 18 right here doesn't have an x, I can't take out an x. I can only take out a -3. So even though I want to take out an x, because I feel like it should have something more complex, the only thing that's common to all of those that I can divide out is -3. So again, I'm going to take my GCF, I'm going to put it out in front because you can't forget about it. And now I'm going to do division. So if I divide these terms right here, sorry, negative there too. So -9 divided by -3 will be a +3. And there are no x's, so my x squared stays the same. And so now let me clean it up a little bit for you. So now if I go and I do these terms here, so 6x divided by -3, so I start with the numbers first. 6 divided by -3 is -2, and again, there's no x on bottom, so I just leave that x alone right there, and it goes into the final answer. And now again, I'll do the last term. Let me clean it up for you a little bit. So now let's do -3 underneath -18. So -18 divided by -3 is going to be a +6. And that's my final answer right there. Don't leave out the -3 GCF in the front. And to check it, multiply back in with distribution. So -3 times 3 minus 9x squared, +6x, and -18. So it checks. All right, one more. Ooh, this is a big and nasty one. So I got 3 terms with larger numbers now, larger exponents, and I actually threw a y in there. So it seems a little complicated, but if we follow those same process, it'll be fine. So I'll give your division symbol here. Down here is going to be our answer. We'll put our GCF out front. So let's start with the number. So I have a 16, a -8, and a +12. Well, right away I can see that I can take out 2. But that would be wrong, because it's not the greatest number I can take out of there. So I need to find out what the biggest number I can take out of there. And if you don't see it in your head, then get on your calculator and start dividing. Divide 16 by 16. See what happens. Divide 16 by 15, by 14. Keep going until you find something that they have that's common, that's the largest number. And hopefully you can see it in your head. The biggest thing they share in common is a 4. That's the biggest number that I can divide out of all those numbers. 16, -8, and 12. I did not make it -4 because I didn't have a minus in front. Right? It was a +16. All right, so now let's go look at the x's. So this one has x to the third. You might think of it as having 3 x's. This is x squared. You might think of it as having 2 x's. And this is just x. And remember, if you don't see an exponent, there's a 1 right there. So now I'm going to take out an x, and I'm looking for the biggest x that I can take out, if I can take out an x from everything. So this one right here has 3 x's to give. I could take a lot. This one has 2 x's to give, but this one only has 1. So I can only take out what each one has to give. So this last term can only give 1 x. So for my x's, the GCF is just going to be an x. And if you want to put the 1 on it to help you think about it when we subtract, that's fine. Now I go to the y's and I look to see if they have y's. They all have y's, so I'll be able to take out a y. And again, I look at the numbers. Y to the 4th, y squared, y to the 3rd. So this first one could give out 4 y's. This one can give 2y's, this one could give 3y's. So one of the biggest thing that they all have, so the biggest that they can all give is really controlled by this y squared right here. So the most I can take out is y squared. So now I know what's going to go in front. 4x y squared. You can put the 1 on it if it makes you feel comfortable. And now let's start doing our division to complete the GCF. Clean up some of these things so it doesn't look so sloppy. All right, here we go. And I might try and do some different colors here so we can see. Let's start with this. I'm going to divide this and this. So 16 divided by 4 is 4. If I look at my exponents for x, it's going to be 3 minus 1 is 2, so it's x squared. If I look at my y's, it's going to be 4 minus 2, so it's y squared. Now I'm going to go to the second term, and let's see if we can use maybe green here. So I'll do this in green. Remember, it's not 8, it's minus 8. Okay? So now I'm going to look at the green stuff. So minus 8 divided by 4 is minus 2. If I look at my exponents, 2 minus 1 on bottom is 1, so it's x, or you can put x to the 1 if you want. And then my y's is 2 minus 2 over 0. Well, that means the y's are canceled out, right? If you want to think about y squared, canceling the y squared on the bottom. So I'm not going to have a y term in that final answer. And then let's do the last one, and I'm not sure this highlighting will work real well, but we'll try it. Let's try blue. And it didn't work. But let's go the last term and the bottom term. So 12 divided by 4 is 3. It's a positive in front. And then x to the 1 over x to the 1, you could do 1 minus 1 and you get 0, so there are no x's. And then for the y's, it's 3 minus 2 equals 1. So it's y to the 1, right? 3 minus my 2 right here. So that becomes my final answer. And if I want to check it, I would multiply in. So let's check it real quick and see if we go back to the original one. And I know it's starting to get a little sloppy with lots of colors here. So let's see. 4 times 4 is 4. X to the 1 times x squared is x to the 3rd. I'm adding the exponents. Y squared times y squared is y to the 4th. Oops. I said 4 times 4 equals 16, but I wrote 4. Sorry. Okay, so the first term's good. Now let's do this next term. So minus 8. X times x is x squared, and then there's a y squared. And then my last term is 4 times 3 is 12. There's an x, and then y squared times y to the 1. I add those, so it'll be y to the 3rd. Let's see if that matches our red equation at the top. We did. So it checks, and this is going to be my final answer. Don't leave your GCF behind. Make sure you have that right there in front. And if you don't want the ones on there, you certainly don't have to do it. They probably wouldn't show up on a multiple choice answer.